Hello students, here we have a semicircle. We want to find total electric field at the center of this semicircle. Or in other words, let's say at point P, okay? So how can we find it? So we know that the semicircle is positively charged. So we have total charge Q. Then we know the radius of the semicircle. And we want to find total electric field at point P. Now, let's say that the semicircle has the length, okay? It's L. Now, if you take the small piece of it, let's say it will be the length of this small piece will be dl because it's very small, then that charge will be dq. Now dq will create electric field de, okay? And if you take at the same distance, let's say this is a small piece of it, and if you draw electric field of that one, it will be de, okay? That one is again dq, and the length of this one is dl. Now if you take it and if you look at it, then you can see that this de converted can be resolved into two components. One will be x1, so this one I call it dex, then up one will be dey, okay? And the same one at the same distance, another one will make again two components. One will be say that it's this de will make dey, and that one will make dex. Now as you can see here, dex has the same magnitude but opposite direction, so therefore all the electric fields that are in x direction will just cancel out. Okay, so let me just, so the only things that electric field will add up will be only in a y direction. Okay, so now say that this is okay, this is our theta. Okay, so if that's a theta, then this is our theta, right? Okay, sorry, that one will be theta. So therefore we can say that our dey is equal de times, that one becomes a sine theta, correct? So the sine theta. Okay, then what else? Then after that, of course, we have to integrate it, you know, to find the total E. If you want to find a total E, okay, total E in y direction. The limits will be what? The limits will be from 0 to the pi. Okay, so that means we have to somehow bring d theta, okay, if you want to integrate it. Now our de is equal to what? De is equal k dq over r squared, right? Now dq is equal to what? dq is equal the lambda dl, right? Then what else? Then we know that since it's L is equal to what? Since it's a semicircle, instead of 2 pi r, we put just a pi r. Okay, what else? Then we know that lambda is equal total charge divided by total length of the semicircle, or dq over dl. Okay, what else? Then this dl, okay, so I try to make it like, you know, zoom one of dl. Say that this is our dl, okay, say this is our dl, and dl will have like this one, okay, and this is our small angle, which is d theta, and this is our r, okay. Then we can say that dl is equal r times d theta. Okay, okay, now let's then keep working on it. We can say that dey is equal de sine theta, okay, integral. So we can say de is equal to the k lambda divided by r. Then we have d theta. Okay, so basically what I did here is I tried to get rid of this dq. So okay, just one moment. So dq is equal to the lambda dl, and dl is equal to the lambda times r, right? r times d theta. Okay, so therefore if we can just clean up this one, then everyone will know that dE is equal k dq over r squared sine theta, right? Then dq is equal to the k lambda r d theta times sine theta divided by r squared. So this r squared will cancel out. Then we have k lambda divided by r. Those are constants, so I brought out from the integration, and sine theta times d theta. Now the limits, as I already said, is from 0 to the pi. Okay, it's e total y. Okay. Then what else? So k lambda over r. Now sine will give you the cosine, right? Minus cosine theta after the integration. Then you have to put the limits from 0 till pi. I think that's it. So the rest of the thing you have to solve it yourself.